ready? Yeah, let's go up. So Sean just mentioned the standard of therapy when it comes to heart. So we talk about heart, we're going to say highly active antiretroviral therapy. You're going to make heart up with ARVs. So when we use the acronym ARVs, it just means antiretroviral drug. So we use ARV drugs to make up heart therapy. We already talked about NRTIs, right? These are the things that are targeting RT, or reverse transcriptase, and they're inhibitors. So nucleoside reverse transcriptase inhibitors. A PI is a protease inhibitor, like we saw on the slide before. The idea is we know that HIV can mutate, right? But when we apply multiple drugs, it has a hard time, the virus does, saying, okay, I can mutate to account for the suppressive effects of all these drugs. And typically, when you have a combination of 3 drugs, you can reduce the viral load and keep it down. So when you reduce the viral load, less replication is happening. Viruses aren't mutating as rapidly because there's not as much of it. And if you are consistent, if you use the drugs consistently, which means taking it at the same time every day, if it's a daily dose, or at the same time twice a day, individuals that are compliant to heart therapy can go a long, long time and live a long, healthy life with a low viral load as long as their compliance occurs. So let's skip that picture. Address label. So these are the pieces on the outside of the viruses, right? So we looked at these pictures here. We see GP41, which is an embedded envelope protein, and GP120. These are responsible for binding. So those are the pieces that the virus is going to use to bind to host cells. And I would say, pause right now if you'd like and figure out on a host cell, on one of our immune cells, what does the binding occur to? So what are the proteins? And we're not going to tell you, but just to supplement your learning, make sure you know which pieces on the host, or you can look on the slide right here. But understand that CD4 and CCR5 and CXCR4 are important. Those are the host pieces to which GP120 and GP41 bind to. This is a picture of how binding occurs. More binding stuff. Notice that GP41 kind of comes out once GP120 conformationally changes. And then CCR5 and CXCR4 are co-receptors, and they're important in bringing the virus closer to the host cell so that fusion can occur. Once binding occurs, we see that the safe gets deposited. We already talked about how the safe gets deposited with the viral RNA and the reverse transcriptase. So you can review that. So these is a recap. So we have the blueprint necessary. We need tools like reverse transcriptase because we have an RNA virus. We need protease to activate the virus later on. And these are the address labels, so GP120 and GP41, right, that allow HIV to attach.
I think we're good on this one. I mean, just look at this picture, make sure that you understand what's going on with the HIV, and you should do great on this section. So
exactly. Not done quite yet, though. I'm sorry. Review viral integrase. That viral integrase is going to take that DNA copy and put it right back into the host blueprint. And then this is real important. I'm sorry to keep it going. This might be a little bit of a long goal. But we have NRTIs, right? These are the reverse transcriptase inhibitors. This shows that these act on the function of reverse transcriptase in the cytoplasm. Integrase inhibitors work in the nucleus to stop replication on this step here. PIs, or protease inhibitors, work outside the cell. So these can really easily get to these viruses without having to get into the cell. We also have other pieces like fusion inhibitors and binding inhibitors that can be used to prevent HIV from attaching. So we're going to talk more about these in detail in the future, but know that these are the drugs that make up that ARV, or HAART, or heart therapy. And be familiar, not necessarily with the names of the drugs, but with where they affect HIV and reduce its ability in the virus cycle to replicate, and also that they affect things that are only specific to HIV to reduce the amount of toxicity that they provide. So again, we've hit on this. We've looked at the differences between virus and bacteria. We've talked about antiviral drugs just now. We know that the blueprint, safe, address label, and tools for HIV are necessary. Know these tools. Know reverse transcriptase, integrase, and protease. Know the viral life cycle. Also know that reverse transcriptase is the reason that resistance can form to antiviral drugs. And we'll talk more about that when it comes to vaccines as well. So good luck studying this section. We'll be back at you with another review shortly.